Hello friends, welcome to our channel Solution with Fun Manual Learners for 2K19. In today's session in the basis of electrical engineering topic, here we are going to discuss with you on the topic today's session that is the resistance and resistivity. Resistivity is also known as resistivity. First of all, we will tell you what basically the resistance is. Basically, we know the resistance is the obstruction to any kind of hindrance to any kind of charge which is moving. So it is an obstruction in the path of movement of any kind of thing. Suppose an obstruction may be considered as a hurdle while a racer is moving inside the in a race. So it is also a kind of resistance. So basically, what resistance is? Resistance is the obstruction to the flow of charge. It means it is a kind of hindrance which is being put in the flow, which is being in the flow of the charges, such as the electrons are moving when the current, such as electron. Whenever the current is made to pass through conducting medium, then some kind of obstruction is to be faced by the charges. So basically, what resistance is? Resistance is the obstruction to the flow of charges such as electron when the current is made to pass through a conducting medium. It can also be defined as the property of a substance due to which it opposes the flow of electrons through a conducting medium. Whenever the electron is passed through a substance, then it opposes the flow of electrons through it. So it is also known as resistance. So when a current is made to pass through an electric field, then an opposing force comes into play is known as resistance. Whenever the current is made to pass through an electric field, then an opposing force comes into play, which is known as resistance. Basically, there are two types of substances in our physics. First one are the good conductor of electricity, such as the metal, acid and salt solutions are considered as the good conductor of electricity because they possess the free electrons. They possess the free electrons, due to which they assume directed motion on applying the electric field, and hence they allow the current to pass through them easily. Hence they possess the minimum resistance. So they are known as the good conductor of electricity because they give minimum resistance, because the minimum resistance means they allow the current to pass through them easily or allow the flow of electrons in an easy going manner. Hence they possess the minimum resistance. And some of the substances such as bakelite, mica, glass, rubber and dry wood are the poor conductor of electricity because they offer relatively greater difficulty of hindrance to the passage of electrons, because they have the greater because they do not have any kind of free electrons present inside them. So they offer the very great hindrance to the electrons, or they do not allow the electrons to pass through them easily. Hence, they are known as the poor conductor of electricity. So our next topic in today's session is what basically the unit of resistance is. Means the SI unit. Basically, the SI unit of resistance is ohm. What is the SI unit of resistance is? SI unit means standard international unit of resistance is ohm. Basically, the conductor is said to have a resistance of 1 ohm when a conductor permits 1 ampere of current to flow through it when a potential difference of 1 volt is applied across it. If the conductor permits the flow of 1 ampere of current when a potential difference of 1 volt is applied. Means when 1 volt potential difference is applied across the two ends of the conductor. Suppose it is a conductor and we have applied the potential difference of 1 volt and the current flowing through a conductor is 1 ampere. Then the resistance faced by the resistance amount is equal to 1 ohm. What will be the amount of the resistance? Amount of the resistance will come out to be 1 ohm when the potential difference of 1 volt is applied. When potential difference of 1 volt is applied across a conductor carrying the 1 ampere current. So our resistance will come out to be equal to 1 ohm is equal to 1 volt divided by 1 ampere. And basically some of the conversions are also available here from kilo ohm to ohm. 1 kilo ohm comes out to equals to 10 to the power 3 ohm. 1 mega ohm comes out to equals to 10 to the power 6 ohm. Similarly, 1 centi ohm comes out to equals to 10 to the power minus 2 ohm. 1 milli ohm comes out to be equals to 10 to the power minus 3 ohm. And similarly, 1 micro ohm comes out to be equals to 10 to the power minus 6 ohm. And the formula to find the resistance is in terms of resistivity, length and area of cross section of conductor comes out to be equals to R is equals to rho L by A. R is equals to rho L by A. Rho is known as the specific resistivity, L is the length of the conductor, and A is the area of cross section. SI unit of specific resistivity is ohm meter. SI unit of length is meter. Area of and the unit of area of cross section is meter square. So in the diagrammatic form, it is presented here as follows. Here A is the area of cross section, means the area where the area of the cross section of the conductor, means the area where it is ending, area of the circular part. And the L is the length of the total length of the conductor which is being taken, and rho is the specific resistivity, which is the internal property of a particular conducting material. And resistance is denoted by R. So formula for it comes out to be rho L by A. What is the formula for the calculating resistance? Formula for calculating the resistance comes out to be rho L by A. So here are some of the specific parameters to determine what when the resistance will be higher and when the resistance will be lower. So when the length will be smaller and area of cross section will be larger, then the resistance will be lower. If the resistance is to be considered as lower, then the length will be smaller and area will be larger. If length is greater and area is smaller, then the resistance will be lower, keeping the specific resistivity rho as constant. Similarly, when we have to keep the length when the length is taken as larger and area of cross section is reduced, and area of cross section is small and length is larger, then the resistance will be more. Then the resistance will be more, keeping the specific resistivity constant. Basically, the specific resistance of a material may be defined as the resistance between the two opposite force of a meter cube of that material when area of cross section is taken out as 1 meter square. Area of cross section is taken out as 1 meter square and length is taken as 1 meter. Length is taken as 1 meter. So our resistivity will be come out to be equals to specific resistivity, because on placing the value of length as 1 meter here, on keeping the value of length as 1 meter and area of cross section as 1 meter square, what we will get? R equals to rho. What we will get? R will come out to be equals to rho, as shown here in the diagrammatic form. Here it is also written here in the diagrammatic form that R is equals to rho when the area of cross section A is taken as 1 meter square and A is taken as 1 meter square and length is taken as 1 meter. So the resistance will come out to be equals to resistivity. Resistance will come out to be equals to resistivity. And basically the dimensional formula for of a resistance is M1 L2 T minus 3 L I minus 2. Dimensional formula for calculating the dimensional formula of resistance is M1 L2 T minus 3 I minus 2. Dimensional formula means the dimensions of which basic dimensions of which are considered in writing a formula. Basic dimensions here which are used in writing which are used to make the complete formula: mass, length, time and current. M is representing M1 L2 T minus 3 I minus 2 is the basic dimensional formula, and how it comes: M is equals to mass, I is equals to current, L is equals to length and T is equals to time. So now here we are going to present the derivation of this dimensional formula, how this dimensional formula of resistance comes out. Basically, we know that the resistance is equals to voltage divided by current. Voltage means potential difference, current means ampere. Voltage, potential difference, voltage the potential difference. So basically the formula of resistance is voltage upon current. For basically the formula for calculating the resistance equals to voltage upon current. Similarly, since voltage is equals to electric field into distance, voltage is equals to electric field into distance. What is the formula for the voltage? Is equals to electric field multiplied by distance. And the formula for electric field is force divided by charge into distance. Basically, what is the electric formula for electric field? Force upon charge into distance. And what is the dimensional formula for dimensional formula of force is m1 l1 t minus 2. What is the dimensional formula of force? Dimensional formula of force is m1 l1 t minus 1. Similarly, here the second quantity in the above formula in the formula of voltage is written here is the charge. So dimensional formula of charge is equals to current into time. What is the dimensional formula for charge is current into time. So what will come out to be the formula for dimensional formula for charge is equals to I1 into T1. Basic formula of charge is current into time, and SI unit of current and the current is represented by I and time is represented by T. So dimensional formula for current comes out to be equals to I1 into T1. So our dimensional formula of voltage will come out to be force divided by charge into distance. In the place of force, what we will write? M1 L1 T minus 2. What we will write in place of force? M1 L1 T minus 2. Similarly, in place of charge, what we will write? I1 T1 raised to the power minus 1. What we will write? I1 T1 raised to the power minus 1. Why? Because charge will come in the upper direction. So our formula for charge will come out to be I1 T1 raised to the power minus 1, and it will be multiplied by length. So basically, what will come out to the final formula for voltage, final dimensional formula of voltage come out to be equals to M1 L1, and L1 will be multiplied by this L1. So L1 into L1 will come out to be L2. L1 multiplied by L1 come out to be L1, and L1 multiplied will come out to be L2. Similarly, this is T2 and T1 raised to the power minus 1. It means minus 2 and minus 1. So time will come out to be T minus 3, and third and the fourth dimension will be I minus 1. So our final formula for the voltage will come out to be M1 L2 T minus 3 I minus 1. Now M1 will be placed directly. L1 multiplied by L1 will come out to be L2 T minus 2 multiplied by T minus 1 will come out to be T minus 3. I1 raised to the power minus 1 will come out to be I minus 1. So final dimensional formula will be M1 L2 T minus 3 I minus 1. On substituting this equation number 2. In equation 1, what we will get? We will get the resistance. What was the formula for the resistance? Resistance formula was voltage divided by current. What was the formula for the resistance? Resistance formula was voltage upon current. And what we have obtained the formula of the resistance in this equation number 2? M1 L2 T minus 3 I minus 1. What is the formula for the voltage? M1 L2 T minus 3 I minus 1 multiplied by I minus 1, because this is divided by current. So current will on coming upper side will become negative. So it will become I minus 1. On multiplying all these things, what will get? M1 L2 will be written here similarly. T minus 3 will be written similarly. But on multiplying I minus 1 with I minus 1, what will get? I minus 2. So the final formula for the resistance comes out to equals to M1 L2 T minus 3 I minus 2. Hence our final dimensional formula for the resistance is M1 L2 T minus 3 I minus 2. So friends, these were the today's session, and this was all about today's session related to dimensional formula of the resistance, and some of the basic key points related to resistance and resistivity, and how to calculate the resistance and resistivity, and what are the factors which determine the resistance, how to calculate the resistance, how to calculate the resistivity, and what are the poor and bad conductors of electricity. So these were all about today's session. So friends, thank you for watching the video. If you liked it, then please like it, and if you have any kind of query, then you can comment in the comment box down below, and please share it with your friends more and more. And if you're not subscribed to our channel, please subscribe our channel. Keep learning, be creative, be intelligent. Thank you friends.